Hello, geometry students. Here in section 8-3, we have special triangles, and we have the 45-45-90 triangle theorem. You saw this in Mathia. And so in this theorem, it says that the legs L are congruent. So we're saying that this is length L, or side L, side length, it's a length of L, my bad. And then the hypotenuse is that same length multiplied by root 2. So in this case, on Mathia, I think they used x, and x root 2, right, as the different ways to express it. Okay, so in this triangle, since this is 90 degrees and this is 45 degrees, this also has to be 45 degrees, so it's a special right triangle. Since this side length is 9, this side length has to be 9 as well. And we know that this side over here, the hypotenuse, is always the length of one of the legs times root 2. So it should be 9 root 2. All right. Okay, find x in this case. So in this case, we have 6 root 2 as the L. Okay, and this side length is 6 root 2. So again, this is L, so we know this is a 45, 45, because those lengths match. Hypotenuse is always L times root 2. So we're going to have 6 root 2 as my L, and we're going to multiply that by root 2. And 6 times root 2 times root 2 is 6 times 2, which is 12. All right, check your progress. Go ahead and pause your video and answer the question. All right, x ends up being 7 root 2. It's that easy as long as you remember that in our right triangle, Mathia, the way Mathia did it, right? They called this x, they called this x. As long as this was a 45, 45, 90 right triangle, and this is always x root 2. So in this case, since our x is already known to be 7, okay, let's cross off that, okay, then the hypotenuse length, right, is just the x times root 2, or 7 times root 2. Okay, check your progress, pause the video, and answer the question. Find the hypotenuse length. If you said 16, you're right. So this will cross out. I like the way Mathia did it, so I'm going to cross out this x here. Right, I'm just going to put a question mark, right? And we already know that this side length, let's call it, we know what it's called. It's going to be called side length, and it was called x. And we know this side length over here is going to be x times root 2. So we have 8 root 2 multiplied by root 2, or 8 times 2, which is 16. Okay, here we're going to find the lengths, the side lengths here. Now, what we know, right, is that this 8, right, is made up of x times root 2. So if we take that equation, simply x times root 2, and set that equal to 8, we can divide both sides by root 2, and you get 8 over root 2 as the value of the in this case they're calling it a, so this side is 8 over root 2. Now they're probably going to rationalize this, most likely by multiplying by root 2 over root 2, so I get 8 root 2 over 2, or 4 root 2, because 8 and 2 reduce. Okay, so the length hypotenuse is 2 times as long as the leg of the triangle. So we have 8 is equal to a root 2. Good. 4 over root 2. All right, check your progress. We're finding the length b. We know we have a 6. Pause your video. All right, the answer is 3 root 2 because 6 is equal to b times root 2. You can solve for b by dividing both sides by root 2. And then just rationalize. Rationalize means you get rid of the square root out of the bottom. You can do that by multiplying it by itself on the bottom and the top. And root 2 times root 2 is just 2. And then 6 times root 2 is on top. And then the 6 and the 2 reduce down to a 3. And you get 3 times root 2. All right, now we have the second special right triangle called the 30, 60, 90. Okay, and the shortest side, which you need to realize, is across from the 30 degree. Okay, across from it is always going to be the shortest side, and we're going to call that S. Now in Mathia they call that just X. Okay, and they called 2S. They called it 2X on Mathia. You know, and in Mathia they called the length across from the 60 degrees just X root 3. Okay, so using S or X is the same thing. Okay, so you need to know those relationships and kind of just memorize this. Okay, so again, across from the 30 is X. Right, across from the 90 degree is 2X, and across from the 60 degree is X root 3. So what are we given here? Okay, we know this is 30, 60, 90. We're trying to find X and Y. So what we know for sure, okay, is across from the 30. Okay, I'm going to cross these. I don't like those letters there. We called X and Y. Okay, across from the 30. Okay, is our shortest side, and I'm going to call that. Well, we can just call that S, I guess. I guess we could use those letters. Let's keep this X and keep this Y. Okay. We know that across from the hypotenuse, that should be 2S. And across from the 60, that should be equal to S root 3. Okay, so Y should equal 2S. Well, guess what? If S is 4 root 3 over 3, then Y is going to equal 2 times S, or 2 times 4 root 3 over 3. Looks like that's going to be 8 root 3 over 3. And if the X length is equal to S root 3, and my S is 4 root 3 over 3, and that's my S value, that's this value, we have to multiply that by the additional root 3, and then we get an answer of just 4. Alright, so there's my 4. And then the length of the hypotenuse is just twice the S. And then there's my 8 root 3 over 3. Alright, check your progress. Go ahead and pause your video and see if you can find the length of the hypotenuse. Alright, and the answer is 8 inches. Let's see why that is. Okay, so we know that this is the side across from the 60 degrees. We know that that's equal to X root 3. We can solve for X by dividing both sides by root 3. That gives me X is equal to 4. But we also know that this side over here is X, and this side over here, across from 90, should be 2X. Well, which side are we trying to find? We're trying to find BC. So we're trying to find the hypotenuse. So twice X, or twice 4, is 8. Okay. Using properties of special right triangles, a quilt has the design shown in the figure in which a square is divided into 8 isosceles right triangles. If the length of one side of the square is 3 inches. What are the dimensions of each triangle? So if the length of one side of the square. So it looks like what they're saying is that this is a distance of 3 all the way down here, then we know that this should be 1.5. Should be half that much. Okay? If these are Saucy's right triangles, then these are 45 and 45. So it's a special right triangle, so this should be 1.5 as well. And then we also should know that this should be the side length times root 2, or 1.5 times root 2. Okay, let's see what they do. Let's go back and see what that said. You know the length of the side of the square equals 3. You need to find the length of the side and the hypotenuse of one isosceles right triangle. Okay, so we're going to find the length of one side of the isosceles right triangle and use the 45/45/90 theorem. So we have 1.5. So we have length root 2, 1.5 root 2. So we have the side lengths of 1.5 inches and the hypotenuse is 1.5 root 2 inches. I guess you could check to see if you're right. It works out. 4.5 equals 4.5. All right, so here you're going to check your progress. Shane designed 2 identical bookends. According to the diagram below, use special triangles to find the height of the bookends. So if we know, remember the 60. So the answer is, pause your video, right? Okay, the answer is 5 root 3. Well, how are we going to know that? Well, we know that this must be a 30 degree because there's my 90 already. So this has to be the smallest side. Remember that smallest side is always called x. The one across from the 90 is always called twice x. And let's get this out of here. And the height, or the length across from the 60 degrees is always x root 3. So since x is 5, then this must be 5 root 3.